Hello everyone, I'm Weilong. I'm from North China University of Technology. Today I will show my work about a platform service for passenger volume analysis on massive smart data in public transportation domain. This is the scenario of our work. From the official statistic in Beijing until the end of the 2015, there are more than 13,000 buses on nearly 1,000 lines has RC card readers, and 44 million RC cards have been released, and there are 15,000 records are generated with about 20 gigabytes daily. So many data was generated, and we have a real project to process it. It is our motivation. The project is the passenger traffic big data analysis platform. We do the work collaborated with Yihualu company. It is one of the biggest Chinese company in transportation domain. We have developed a bus dispatching system for more than 13 new night buses in 2014 to release the traffic jam, improve the air quality, and do some development coordinately with other cities. You see, in the project, we get so many data. They are smart car data. In this table, we can find about 30 attributes in the data. The data is generated during continuous days, and they are generated by the behaviors when the passenger getting on and getting off. We can see it is typical spatial temporal data because they have three types of the attributes about entity, time, and space. The smart card data was stored in traditional database, not in traditional ways. So the business analysis were regularly executed, but the latency on massive data is too long to endure. So for traffic volume analysis, there are technical problems. The first is the executive latency. The second is accuracy is not very well. The third is the scalability is poor when the data or infrastructure update. So we propose a path for bus passenger volume analysis. From the figure of our architecture, we can see four layers. One is the infrastructure layer. It is our private cloud. The other layer is a data layer. In this layer, we maintain the basic data about basic information of lines, buses, vehicles, and bus stops. And the other is the business data, like the RC card data. In the processing layer, we do some business analysis, such as passenger volume analysis. There are jobs executing in this layer. The top layer is the application layer. From the result in the processing layer, we can do some visualization in the map application, or we do some management about the analysis. We can do some job submission, job stop, and other functions. So in our path, we can do the passenger volume analysis. There are three behaviors when a passenger go to the bus stop. One is the getting on, one is getting off, the other is the transfer. So we can give three sub-definitions about passenger volume. For the getting on passenger volume, there are three difficulties on smart card data. First one is how to discriminate the different trips of the bus, because one bus can do more than one round trip in a day. The second one is how to infer the stop and start time of a bus. From the data, we can see there are only the passenger's time step is kept instead of that of the buses. How to infer the time of bus is one significance. The third one is how to sensibly count the passenger volume in given time slot. It is important if the wait period of a bus overlaps two adjacent durations. So we propose the first algorithm about the bus trip recognition. We do this algorithm use the statistical observation and do some data processing. We found that the data, the time steps of the data has the positive skewed observation. We found the median of the getting on time steps is smaller than their mean values. So we can do some transformation to transform the time steps to comfort the normal distribution. We do this work by the log transformation. And we also use some business restriction. For example, in Beijing, there are at least 7 minutes for a single trip. So the trips for a bus vehicle, we can cluster the trips by their times. So we do this work through two jobs of MapReduce. We implement the first algorithm. The first job is to get the volumes of the given bus vehicle. The second one is get all of the bus vehicles. So we can see some result example of the first step and the second step. In the example, we can see at a specific station on a certain day, the count of the passengers can be achieved in different time slots. The other passenger volume is done in our work. Besides the ones in getting on or getting off analysis, there are additionally two difficulties for the transfer passenger volume. The first one is how to depict the spatial neighborhood of any station. The second is how to depict the temporal closeness of any passenger for transfer behavior. Because the behavior of transfer are between his getting off behavior and the successive getting on one. So we do the second algorithm about transfer behavior recognition and counting. In this algorithm, we use some other business restrictions about time and space. In official documents, we found 95 passengers are expected to wait less than 20 minutes, and only 16 passengers would walk more than 1,000 meters to the next getting on station. So we can use this restriction about the time and the space. The time restriction is 20 minutes, and the space restriction is about 1,000 meters. We also implement the algorithm through MapReduce, and we use two jobs. One is to find the transfer behavior, the other is to count the transfer volume. We also see the result example of each behavior, each steps. We can see at a specific station on a certain day, the count of the passengers can be found in different time slots in a day. We do our work through some evaluations. We do this evaluation in our private cloud in our laboratory, and some real smart card data of Beijing buses are used here. This picture is captured from our system. See, in this picture, we found the traditional way, ODE, has a longer latency than our BD method by 2 orders of magnitude. For both getting on and transfer volume behavior analysis. I think the low latency of our BD comes from the parallel execution of two-step procedure through our Hadoop MapReduce framework. And the traditional ODE method requires multiple data scans to store and query on single machine without parallelism. So it requires much time to complete. In these two experiments, we found both getting on and transport volume analysis are proved scalable. They are stable and horizontally scalable in two perspectives. And we also do some case studies in our project. We can see how to submit a job, how to find the visual effect in our application, and we can do some synthetic views by the result from the jobs. This is for the getting on analysis. This is for the transfer behavior analysis. Okay, this is our conclusion. We propose a dedicated path for transfer for the passenger volume analysis. Our service can hold minute-level latency and keep nearly linear scalability. The feasibility and efficiency are proved quantitatively in a project. So this is our work today. If you have any questions, you can contact me in this email. Thank you.